2.3, we started last time looking at set operations. Specifically, we had talked about 3 set operations. Intersection, things that they have in common, right? That was this one, like the intersection of streets. We talked about, oh, I missed one. We talked about the union. Union means the joining of 2 groups of things and you get everything, right? We talked about it being kind of like a marriage. And then the third one was difference of sets, where we're talking about it like a prenup, where we remove everything that we've got joint and we come out of it with just the part that's in A only or B only, okay? So what we're going to do today is we're going to talk about ordered pairs and the Cartesian products. So you know what ordered pairs are from the perspective of algebra, and they work very similarly for what we're looking with in set theory. So if you have 2 sets, A and B, then the ordered pairs are items that come from set A in the first spot of the ordered pair, and items that come from set B in the second. And in general, AB does not equal BA. In particular, it may not even be one of the ordered pairs you can have, because the first spot right here has to come, sorry, change the color here, has to come from the set that's listed first. In this case, we called it set A. And the second location in the ordered pair has to come from the second set listed, which we called it in this case B. Okay, so we're going to do an example. Before we get there, let me talk about what a Cartesian product does that it relates to ordered pairs. Cartesian products are the collection of all the ordered pairs that you can make with 2 sets. So while intersections, unions, and difference of sets create another set that just has elements from whatever you're looking at in it, Cartesian products actually create ordered pairs, and those are the elements of that set. All right, so we've got a universal set. It's the letters A through G. We've got X, Y, and Z. These are how we defined them last time when we were working with these examples too, so it's just the same. And we're going to find X cross Y. So what that means is that I take the first element in X, that's an A, and I join it with the first element in Y, happens to also be an A, and it creates the ordered pair AA. And I'm going to use the same first letter, A, right here from set X, and do the same thing with the other letters in Y. So I'm going to do A with the B over here in Y. And then I'm going to do the A with the C that's over here in Y. I'm not done, but that's all the ordered pairs that I can make, starting with the first one in A, first one A in set X, and pairing it up one at a time with the items in the second set. That's all the different ways I can make that pairing. And then I just go to the next letter that's in set X. What's the next letter in set X? C. And I do the same thing. I take C and I group it with the first item in set Y. That's A. And then I do C with, what's next?
B.
B. And then I have C with C, right? Okay, so at this point I have taken care of grouping the A and grouping the B, and I'm on to grouping E. So now I have E, what? A. And then E, B, and E, C. And then our last one, G, has G, hang on, G, A, G, B, and G, C. And this is a set of ordered pairs. So it's a practical sort of thing where you might have seen this used before. So when I grew up, my mom had 3 children, and my mom's best friend had 3 children. And we all liked to hang out together, right? But I didn't want to hang out with my brother and my sister. I wanted to hang out with her girls, right? And the same thing was true for her girls. They didn't want to hang out with their sisters. They wanted to hang out with people from my family. So you'd see us pair up, right? Well, this is all the pairings that we could make doing this. Each person in my family had, like for me, I had 3 different girls that I could hang out with. Now, I was most likely to hang out with the one that was my age, but it didn't always work out that way, right? It's all the pairings that I could make between the people of my family and the people in her family. That's what this is. It's a list of pairings, okay? So what we're going to do then is we're going to talk about how many items we see here. So if you take a look at this, actually, let me do it from here first. How many items are in set X? How many elements? 4. Okay, so the number of items in set X is 4. And the number of items in set Y is what? 3. And how many different pairings do I have done here? There are 12. What do you think's happening?
Multiplication.
It's multiplication, right? It's multiplication. And that's exactly what this says on the next screen. If I have a set A and a set B, and I want to find the number of pairings, right, the number of ordered pairs, the number of the Cartesian product, then I need to figure out how many items are in set A and multiply it by how many items are in set B, and that will create at least a check for me to know that I got them all when I wrote them out. Right? If there's 4 items in set A and there's 3 items in set B like we just did, there should be 12 pairs of ordered pairs, right? There should be 12 ordered pairs in my group. So taking a look down here then, we have the same question that we had before, and we're actually going to write it in on this screen now. So we just said the number of items in set X was 4, and the number of items in set Y was 3. And sure enough, that means the number of items in X cross Y should be 4 times 3, which is 12. How about I write 12 instead of 13? It's 12. And if we flip back to my screen before, we saw that that's exactly what we had with an example. And it works every single time. So be careful inside of my math lab. They could ask you to find X cross Y. Or they could ask you to find N of X cross Y. Those are different questions. Over here, X cross Y means I have a list of ordered pairs, right? And on this one, N of X cross Y just means I need to figure out how many ordered pairs there are, which means I don't necessarily have to list them all out to do that. I've got a counting strategy that I can use instead. So don't do more work than the problem's asking you for, not only just because it's going to be wrong when it hits back at you, but then you're going to create yourself a time, drain, right? It didn't need to do that. So be careful. Yes?
It was 4 times 3, right?
Yes. Sorry, that should have said 4 times 3 equals 12. Sorry. I was cutting to the answer already. Thank you for helping me fix that. Yeah, 4 times 3 is 12. Okay. With that fixed, is it okay?
Yes.
Wonderful. Please. Here's the deal. I'm going to make mistakes. I'm pretty sure I've done one every class at least. Okay? So just tell me when it looks like something looks wrong, and we'll discuss it. Maybe I'm wrong, or maybe you're misinterpreting what I'm saying, but we'll fix it. Okay? Let me know. All right, so the next screen actually is a fantastic place for us to put all of what we've done together. These are all the set operations that we've discussed here. So when it comes to doing your homework, your quiz, your exam, this chart, putting it all in one place will be a helpful place for you to look. So these are the 5 different ones we've discussed. The first one actually occurred in a previous section. It's called the complement. So the complement of A is the set of all X such that X is in the universal set, but it's not in A. And then the rest of them came about in this section. The intersection, the union, the difference, and then the Cartesian product. So I'm just going to quiet and let you write those down. All right, the other thing that we did last time in this section is we drew some pictures of intersections and unions and differences. You remember doing that? What were those pictures called? Venn diagrams, okay? Venn diagrams. So what we're going to see happen in the rest of this section and in the next section is uses of Venn diagrams, okay? So in this section, we're going to talk about joining them together with these operations and which pieces of the picture we're talking about. We're going to do that by asking the question about shading. Okay, I'm missing one. Okay, I am missing a slide. I'll go over here and put it in. Number 6. Number 6 says that we're going to do A complement union B. Okay. So we have 2 sets, which means we're going to have 2 overlapping circles, and they're going to be drawn inside of a rectangle. So the rectangle. We have our 2 overlapping circles. Here's A, here's B, and here's my universal set. Okay, so what I'm going to show you is foolproof. And half of you aren't going to do it anyway, because you're going to think you're going to be able to figure it out without doing it this way, and sometimes you're going to be right, and sometimes you're going to make mistakes. Okay? So this is a foolproof way to do this. And I would encourage you to take that seriously and just go through the steps so that you get them right. So what we're going to do is we're going to label each one of these areas of the graph with a number. And I'm going to start with the outer circle of A. I'm going to move to the overlap, the outer circle of B, and then the outer rectangle. Now with a diagram like this, you can probably ignore what I'm telling you, and you can probably get it right pretty okay. But if you take a look at 7 and 8, you'll see that we have 3 overlapping circles, and it is much more difficult with 3 overlapping circles to figure out what it is that's going to be the answer without an organized, structured way to do it. So if it feels like overkill right now, I understand that, but hold tight, it won't feel like overkill in the next problem. So what we're going to do is we're going to write down A complement, and we're going to write down which numbers satisfy the condition for A complement. So A complement means it's not in A. So we've got numbers 1, 2, 3, and 4. Which numbers are not in A? 3 and 4. So I'm going to write them down. 3, 4. Okay, everybody good so far? The next one is B, and it's not B complement, it's actually B. So what numbers are actually in B? 2 and 3. I've done each of the individual pieces, and now I'm going to join them together with the symbol between. What is that symbol that's between? It's U. What does U stand for? Union. Union. This U is union. The outer, oh, it disconnected. Okay, back to it. Union, right? We're going to do a union. So we're going to join A prime union B. What does union mean? Together, unite. We get everything, right? We get everything. So taking a look at the list of numbers above that horizontal line I just drew, I need to include everything in my list of numbers, but I don't need to do overlap. I don't need to write something twice. So what numbers are going to be included in the list that I'm writing now? 2, 3, and 4. Everybody good? Okay. That's the work you're going to do to be able to shade the diagram, which is the directions on the problem. Okay? And inside of my math lab, what it will do is it will tell you, it has it looks like a paint symbol where like you drop the color into the boxes. And so you're just going to go back over here and you're going to drop the color into the boxes or the areas of the graph for 2, 3, and 4. That's kind of messy, but that's what it would be, the shading of those places on the graph. 2, 3, and 4. Okay, I feel like this is kind of like a puzzle. It's going to lead us to what we're doing in 2-4, which is an application. So right now we're just getting used to the idea of how to join these items together. Any questions on this one? Then let's do groups that have, or problems that have 3. Okay, I need 3 overlapping circles. So 3 overlapping circles, well, we'll do our rectangle first. 3 overlapping circles starts to look kind of like, the Olympic rings or something, right? All right. Typically, we write them kind of in alphabetical order. A on the left, B on the right, C on the bottom, and the universal set U. Obviously, if I had three circles, they wouldn't all have to overlap. So you could see something inside of my math lab where two circles overlap and the other one doesn't overlap one of them or something like that. It's fine. You do the process the same way. You're just going to label the regions with numbers. So we're going to label the regions with numbers just like I did in the last problem, and then we're going to go from there. So even if the picture doesn't start like this, the process is still the same. Label each of the regions with numbers. So I've got 1, 2, 3, 4, 5, 6, 7 at the bottom, and 8 on the outside. And if you choose to number them differently, it's okay. Remember, your answer is not the numbers. Your answer is a shading of a diagram. So it doesn't hurt anything if my numbers and yours don't match. For the purposes of doing it together, it will help you if you just match for now. Okay, so we're going to go through the different pieces of the statement that we're given. Now, just like in algebra, parentheses, we're going to start inside of them, right? It means those grouping symbols means that's where we start. So starting inside of those parentheses, first I have A. What are the numbers that are in circle A? 1, 2, 4, and 5. Also in the parentheses is B. What are the numbers that are in B? 2, 3, 5, 6, in whatever order you like. Now, that's the two individual pieces within the parentheses. Now we join them together with what symbol? The upside down U. What does it mean? Intersection. Okay, intersection. What is intersection? What's an intersection of streets?
Being the numbers that they have in common?
The numbers that they have in common, right? The intersection of streets is where they cross. It's what they have in common. So numbers they have in common. So looking at the list of A and looking at the list of B, what numbers do they share in common? 2 and 5. Everybody good so far? Okay, we've done everything inside of the parentheses now. So now we move to the outside of the parentheses. We have another set, C. What numbers are in C? Okay, we'll put them in order. 4, 5, 6, 7. Is that right? Okay. Now, these two pieces, right, namely this one and this one, are the pieces up here, piece 1, piece 2, that we're supposed to join with this symbol now. What's that symbol? It's a union. So now I need A intersect B, those values, union with C. What does union mean? You get all of it. It's the marriage, right? You get everything. So these lists that I had that are numbered 1 and 2 right now in the yellow, those lists are going to be merged together now, and I'm going to write down everything, not just what they have in common, but everything without overlapping a number, right? I don't need to write it twice. So what numbers do I get if I use both of those lists and write everything? 2, 4, 5, 6, and 7. So what do I do with that information? I go back and I shade my diagram. So we're going to shade the part of 2, the part that's 4, the part that's 5, 6, and 7. It's really easy to miss a piece if you don't put the numbers in. I will tell you, this is not how I've always taught this material. I had a student show me something at one point, and I thought, this is foolproof. This is great. I can make sure I get it right every single time. There's no questions if we put numbers in the regions. Okay, let's do another one together. We have A intersect B prime, intersect C prime. Okay, 3 pieces, so 3 sets, so 3 circles. I have A, B, C, and the universal set. Put my numbers in the same way every time so that I don't have to think about it. 1, 2, 3, 4, 5, 6, 7, and don't forget the outside is 8. Okay, starting inside the parentheses, what's the first item I'm going to write down? A. And what numbers are in circle A? 1, 2, 4, 5. What else is in the parentheses? B prime. Problem so far is starting out like the last one. Now it's different because it's prime and not just B. B prime. What does B prime mean? Everything not in B. So I want to list everything not in circle B. So what numbers are not in circle B? 1, 4, 7, and 8. Okay, inside the parenthesis, I've done the individual sets. How am I joining them together now? Intersection. And intersection means what they have in common. So looking at those lists, what do they have in common? 1 and 4. All good? Okay, that's all its part that's in parentheses is finished. Now I move to the outside of the parentheses. What's outside my parentheses? C prime, which means what's not in C. So what numbers are not in C? 1, 2, 3, and 8. Okay, those are the two pieces of information that are going to be joined with what symbol? Yep, intersection. And intersection means what they have in common. So looking at those two lists that are in between the horizontal lines, what do they have in common? 1, and nothing else, right? Nothing else. So my shading just looks like that. It's a puzzle. You can do it.